Hello. It's fun and games with implicit differentiation, also known as page 162, 1 through 35 odd. Whoopee! Alright. Number 1. We want to find dy dx, and we are given x squared y plus xy squared equals 6. So just go ahead and take the derivative all the way across. These two are product rules. So first times the derivative of the second plus the second times the derivative of the first 2 times. So first this one. That's the first times the derivative of the second plus the second times the derivative of the first. All this is from that. And then we have the first times the derivative of the second plus the second times the derivative of the first. All this comes from there. Equals 0. The derivative constant is 0. Now we're just going to get the dy dx separated off by itself and clean up a bit. So we're going to keep all the dy dx's on this side, throw everything else to the other side. So x squared dy dx stays. 2xy goes. 2xy dy dx stays. Y squared goes. And that's it. 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. So we factor out a dy dx. X squared plus 2xy. And that's equal to negative 2xy minus y squared. Divide out both sides. X squared plus 2xy. Divide this side out the same. And we get dy dx equals, let's see, negative 2xy minus y squared all over x squared plus 2xy. Alright, so just product rule twice. Remembering that when we differentiate y, we have to apply the chain rule to get the dy dx in each case. Not bad. Have paid for first problem. Second problem. Y squared is equal to x minus 1 over x plus 1. Alright. Take the derivative of both sides. With respect to x, so we'll get 2y dy dx. And this is quotient rule. Bottom to top, top to bottom, all over bottom squared. Okay, so that's bottom d top minus top d bottom all over bottom squared. That's 2y dy dx. This is equals x plus 1 minus x minus 1 all over x plus 1 squared. That's going to be minus x plus 1. So x minus x, those just go out. And 1 minus negative 1 is 2. Alright. Multiply both sides by 2y. You get dy over dx. Divide both sides by 2y. Get 2 over 2y x plus 1 squared, which those go out. Equals 1 over y x plus 1 squared. As far as we can go. Number 5. Taking the derivative of x equals the tangent of y. So dy dx. Derivative of x is 1. Derivative of tangent is secant squared. We've taken the derivative of something which might have a further derivative, so we're going to chain rule it. So we divide both sides by the secant squared of y. And then secant is already 1 over cosine, so 1 over cosine is just cosine. There we have it. Number 7. Taking the derivative of x plus the tangent of xy equals 0. So the derivative of x is 1. Derivative of tangent is secant squared xy with the derivative of xy. Derivative of xy is first times the derivative of the second plus the second times the derivative of the first. So we're taking the derivative of tangent of xy. Tangent went immediately to secant squared, kept what was inside, and then needed to differentiate xy. That's x times y, product rule. First derivative second plus second derivative first. And so this becomes plus secant squared of xy. This is times x dy dx plus y equals 0. Need to get our way into here somehow. So let's start peeling them off. Subtract 1 from both sides. Divide both sides by secant squared. So got x dy dx plus y equals negative 1 over secant squared. We just saw in the last one that secant squared was cosine squared, or 1 over secant squared was cosine squared. So that's going to give us negative cosine squared xy. We subtract y from both sides. Divide both sides by x. So dy dx equals negative cosine squared xy minus y all over x. All right, number 9. Still finding dy dx because we're looking for the slope of the curve. We need to do it at a particular point. So our function looks like x squared plus y squared equals 13. And I circle of radius radical 13. We want the slope at negative 2, 3. So take the derivative with respect to x. We get 2x plus 2y dy dx equals 0. And we'll solve for dy dx. So it means we subtract 2x, divide by 2y. We get dy. I'll write it out. 2y. 2y. Those go out. dy over dx is negative x over y, because those 2's cancel. All right, here's our x and y. So our dy dx evaluated at negative 2, 3 is going to be negative 2 over 3 equals 2/3 is our slope at the indicated point. Number 10. Whoops, not number 10. Number 11. Let's see. We've got, oh, nice little circle again. Same size, just moved to the right one and up one. So that's x minus 1 squared plus y minus 1 squared equals 13. I want our slope at the point 3, 4. we take our derivative. It's going to be 2 out in front, x minus 1 to the first, times the derivative of x, which is 1. Good old chain rule. Plus 2 times y minus 1 times the derivative of y. Alright, so we wind up with 2x minus 2 plus 2y minus 2 dy dx equals 0. Subtract these, divide by that. So we'll wind up with 2y minus 2 dy dx equals 2 minus 2x. We subtracted 2x from both sides, added 2 to both sides. And we divide by 2y minus 2. And we'll get the dy dx. 2. There's far too many 2's. Let's get rid of almost all of them. 1 minus x over y minus 1. You can cancel fractions like that if you take the same number out of every single term. So divide by 2, divide by 2, divide by 2, divide by 2. Need this at 3, 4. So dy dx, evaluated at 3, 4, is going to be 1 minus 3 over 4 minus 1, negative 2 over 3. So our slope is negative 2/3. That particular point.